Hello friends, welcome to EDUBLOG. It is still your master Tonio, and today in mathematics we'll be looking at probability. But before we start, I would love to say a big thank you and give a big shout out to all our friends and family out there, all our followers, all our viewers out there. You guys are the best. And if this is your first time on joining us on this channel, please do ensure to hit the subscribe button, hit the notification button, so that whenever we drop new videos like this, you'll be one of the first to get them to be notified. And please don't forget to give a thumbs up too. That means to like our video so that it can help YouTube algorithm. Just like I said, today we'll be looking at probabilities, and what we have here is our objectives for today. We'll start by defining probability and its formula. Now, after which we'll go to the forms of events under probability. Now, under the forms of events, we'll be looking at our independent events, we'll be looking at mutually exclusive events. After which we'll go to types of probability. Under types of probability, we have what we refer to as one probability. We have what we also refer to as zero probability. We have our multiplicative probability, which somehow finds itself under independent event. We also have additive probability, which is also under mutually exclusive events. After which we'll go to probability games. Under probability games, we have our coin game, we have our fair dice or Ludo game, we have our card game. Now, before we go into the topic proper, if after this video you have any question, please don't forget to drop the question under the question section. Now, at the dashboard, we have the links to WAEC past questions, Jamb past questions, post-UTME past questions of any school you can think about. So, why not follow the link on the dashboard? Alright, we'll start from the definition of probability and its formula. Probability can be defined to be a measure of the tendency or the possibility of a particular event to occur out of a total number of possible events. Now, this total number of possible events is also known as sample space. Now, before I go into explaining probability proper, I would also like us to understand what we mean by an event. An event simply means a set of possible outcomes of an experiment. An event or event simply means the set of the possible outcomes of an experiment. So when you talk about probability, there are certain terms I need you to understand. Now, in probability, I want you to know that there must be an experiment, and this experiment will have to lead to a group of events. Alright, now remember, we have one single event, right? And we also have multiple events or group of events. Now, this group of events is known as sample space. So mathematically, we have that the probability of any event occurring is equal to the number of that event all over the total number of possible events or simple sample space. And what do we mean by that? Let's use our fair dice game, for example, our Ludo. I believe that we all know what a Ludo is. A Ludo is a game, right? And this game, each dice is made up of 6 faces. Now, this means that in the rolling of a Ludo dice, or in the rolling of a Ludo, we have the possibility of one of the 6 faces occurring, right? So let's say our Ludo, our expectations whenever we roll a Ludo is to either have a 1, or a 2, or a 3, or a 4, or a 5, or a 6. Right? So now the game itself, the Ludo game itself, is our experiment. Now, this experiment has these 6 possible occurrences, which is it's either we have a 1, or we have a 2, or we have a 3, or you see a phase 4, or you see phase 5, or you see phase 6. Now, each of these phases is known as an event. Now, each phase is an event that can occur from the experiment of the game. And the experiment is the rolling of the dice, right? Now, how many events can possibly come out from the rolling of a Ludo? We have 1, 2, 3, 4, 5, 6. Now we have 6 total number of possible events. Now this 6 total number of possible events is what we know as our sample space. Alright? So our sample space is the total number of possible events that can emanate from what? From our experiment. Alright, let's look at a practical exam question on probability. Alright, let's look at an example that will probably help us understand this probability better. What is the probability of picking a yellow ball from a bag made up of 2 black balls, 3 yellow balls, and 5 green balls? What is the probability of picking a yellow ball from a bag made up of 2 black balls, 3 yellow balls, and 5 green balls? Now, these are put another probability, right? Remember what we said earlier? We said that in probability we have basically three components of probability. Now we need to find out the events we have to look for, right? The total number of events that we're looking for each possibility or each probability. We need to find out the total number of sample spaces that are occurred in that particular experiment. Now in this question, what is our experiment? Now our experiment is picking a ball from a bag. Remember, that's the beginning of probability. Our experiment is picking a ball from a bag. And we say that our experiment will always be made up of what? Sample spaces, right? Will always be made up of events. Now, what are the events that can occur? Now, the events in this our bag, or that can occur from our experiment of picking a ball from a bag, is we have 2 black balls in the bag. We have 3 yellow balls in the bag. And we have 5 green balls in the bag. So the events that can occur from picking a ball from our bag is either you pick a black ball, or you pick a yellow ball, or you pick a green ball. Now these are the possible events that can occur. And from a mathematical definition of probability, we say that probability of any particular event occurring is the number of that events all over the total number of possible events, right? So we have that the probability of picking a yellow ball from this our question is probability of yellow ball. Now our event is yellow ball, right? Will be equal to number of yellow balls all over total number of balls. So we have that probability of picking a yellow ball from our bag is the number of yellow balls in the bag all over the total number of balls inside that bag. From our question, we have how many yellow balls in the bag? We have 3 yellow balls. So we have our probability to be 3 yellow balls all over the total number of balls. Now remember, the bag is made up of 2 black balls, 3 yellow balls, and 5 green balls. So we have 2 black balls plus 3 yellow balls plus 5 green balls. So our probability to be 3 all over 10. So we have that the probability of picking a yellow ball from a bag made up of 2 black balls, 3 yellow balls, and 5 green balls is 3 out of 10. Now remember, we have 3 yellow balls, right? And these 3 yellow balls can be found from the midst of 10 balls in total. Up next will be forms of events. The first form of events I would want us to look at is events known as independent events. So what are independent events under probability? Now say that independent events under probability are 2 events that occur independently of each other in an experiment. So what does it mean? Now it means that the occurrence of one does not affect the occurrence of the other. Now for example, let's look at a coin, the tossing of a coin. Now we all know that in a coin we have just 2 sides of a coin. We have the head and the tail. So in the toss of a coin, it's either you get a head or you get a tail. If I should toss a coin for the first time and I get a head, and I toss again for the second time, I can get a tail or still a head. Now this independent event simply means that my first toss of the coin does not determine whether I will get a tail or a head in my second toss. So event A of my getting a head does not depend, or let's say my event B does not depend on the outcome of what I got in my very first event. Now also in the rolling of a fair dice or a Ludo, right? If I should roll a Ludo for the first time and I get, let's say, phase 1, my result or the outcome of my second roll is not dependent on my first roll, on my first result, on my first event. If I should roll for the second time, I still have the same number of chance. I still have the probability of getting a 1, or 2, or 3, or 4, or 5. So events like this, of which your first event, or the outcome of your first event, does not determine the outcome of your second event, is known as independent event. Alright, another form of events we'll be looking at is events known as mutually exclusive events. The second form of events is known as mutually exclusive events. Now, what do we mean by mutually exclusive events? We say two events are mutually exclusive if the occurrence of one event totally eliminates the occurrence of the total events. Or we can say that two events are mutually exclusive if the two events cannot occur at the same time. So for example, let's use our coin, the toss of our coin as an example as well. We all know that a coin is made up of two sides, right? The head and the tail. So in the probability of tossing of a coin, it's either we have a head, it's either you see a head or you see a tail. Now, but one thing that is impossible to occur is having your head and your tail at the same time, right? So we have that the probability or the possibility of getting a head and getting a tail is mutually exclusive events. Why? Because I cannot have a head and a tail from one possible toss. Alright? So the probability of getting a head is mutually exclusive to the probability of what? Getting a tail, because they cannot occur at the same time.